Hello student, hi, good morning, hi. So today we are going to start our lecture in what effective mass, okay, in effective mass. And we have seen the effective mass. For effective mass we have seen what analogy in last class, okay. So now we have got some clue about what exactly the effective mass is there, okay. So now we will come to the point of effective mass, what actually the effective mass is there, okay. So now let us see effective mass, effective mass, effective effective mass, effective mass where in inside the semiconductor, okay. So we are going to see what exactly the effective mass. See, we have one crystal, okay, we have one silicon crystal. Let us assume we have one silicon crystal, okay. So this is my silicon crystal, okay. So now inside crystal there is so many electron, okay. So inside crystal which is moving. So now if I will say like that, one electron is inside crystal, okay, one electron is outside the crystal, outside the crystal. Now I am asking you, so the movement of these two electrons, one is at in the free space, one is inside, one is inside crystal. So which one particle or which one electron has higher momentum, okay. So both the electron have same momentum, either both have different momentum. So let us think, is it different or same? So the moment is different, okay. So the electron inside the crystal has actually in generally different movement compared to the electron in the free space, electron in the free space. What is the reason, what is the reason behind this? The reason is that before what before knowing this reason, we should what we should we should first know about what energy band formation, okay. If you know about that energy band formation, then you will come to know how the movement of electron is different inside the crystal compared to the electron in the free space, okay. So see, as we have seen very well what the formation of energy band, formation of energy band, okay. The formation of energy band during the what for during the for that during the formation of a solid or crystal, okay. During the formation of solid and crystal, if you see what we got here, we got one conduction band, one conduction band, one valence band, okay. One conduction band or one valence band. This is nothing but what exactly this what energy band means, a discrete energy level, okay. So this is what one group of discrete energy level, okay. So which is distributed. So it is not continuous, but this is a band, okay. So this is what band we have seen that, okay. So it's a quasi distribution of discrete energy level, okay. Discrete energy level. So therefore almost we are representing it as what almost continuous, okay. So this is what energy band gap between these two allowed energy band, okay. So this is valence band, this is sorry, so this is my valence band and this is my conduction band, okay. So now see here at what, at temperature 0 degree Kelvin, 0 degree Kelvin, this valence band is almost full of what, electron, almost full of electron, okay. So this is almost full of electron, okay. Means all the state are filled with electron, but in conduction band all the state are empty, okay. All the state are empty in conduction band. This is not whole, okay. This is empty state or empty state or quantum state or energy state, you can say, okay. Energy state which is empty, no free electron under what, 0 degree Kelvin. Now when we increase the temperature When we increase what temperature, temperature not equal to 0 degree Kelvin. See now, when the temperature is not equal to 0 degree Kelvin, means this temperature is what? This temperature is greater than 0 degree Kelvin. Then that time what happen? Actually this electron. Why I am saying this all things to understand this. Okay. So after within minute you will understand why the movement of this electron inside the crystal is different from the movement of electron in free space. Okay. So now this is my temperature greater than 0 degree Kelvin. Now here what happen? This electron will what? The electron here, electron in the valence band, they will gain some thermal energy. Okay, so then they will break out the covalent bond and come out of the bound state or from the atom and jump to the conduction band. Jump to the conduction band where they will jump in the conduction band. Okay, so in the conduction band there it become free. Okay, it become free, and this conduction band here inside the crystal is nothing but it is a interatomic what? Interatomic space. Okay, interatomic space. Okay, so conduction band means interatomic space. Okay, within the crystal means electron is free. Electron is free means not totally free, it is free inside the crystal. Inside the crystal. Okay, so we are talking about the movement of electron inside the crystal in where? In conduction band. Okay, in conduction band within interatomic space. Within interatomic space. Now what happens when the temperature is greater than 0 degree Kelvin? Then there is a creation of what? Positively charged empty state. Okay, so then there is a creation of positively charged empty state. This is what hole. So this is what? Empty space. Empty space. Now there is a positive. Okay, so there is a positive charge means as as you might know that when someone will what? Donate, so their charge will come what? Positive. Okay, so this electron, let us say this electron will jump to this side. Okay, so this side, because here the electron has jumped to where? Conduction band. Okay, so this is what? Hole. Now the electron which is present here, it will jump to this what? This positively charged empty space. Okay, so this is my now electron and this is my hole. Now this has positive charge and this has negative charge. Okay, so this has positive charge, this has negative charge. So between these what? Between these there is a what? Force of attraction. That force is what? Coulombic force of attraction. Okay, Coulombic force of attraction. Now this electron is moving. Okay, so which type of electron is this? This is bound. This is bound electron which is moving from one bound state to another bound state. Okay, so which is moving from one bound state to another bound state. Okay, so now this force of attraction between these positive and negative charge. Okay, positive and negative charge will what? Will influence or affect the motion of electron inside the crystal. Means motion of electron inside the crystal means here motion of electron in the conduction band, means motion of electron in interatomic space. In interatomic space. Okay, so this is what? Due to which its mass will get affected. Its mass will get affected. Okay, its mass will get affected. Okay, so this is what basic concept. Why? Because inside the crystal there is a conduction and valence band. When the temperature increases, means greater than 0 degree Kelvin, then this electron will jump to the conduction band. There is a creation of hole. That hole has what? Positive charge. Okay, positive charge, and electron has negative charge. Then this electron is what? Bound electron which is moving from one bound state to other bound state. Okay, so there is a negative and positive charge. Wherever there is a negative and positive charge, there is what? There is an electrostatic force of attraction. Okay, which is Coulombic force of attraction. Okay, or electrostatic force of attraction, which will influence what? Which will influence the motion of a electron or affect the motion of electron inside what? Crystal. Means motion of electron in what? Conduction band, in what? Interatomic space, in what? Inside the crystal. Inside the crystal electron is free, means where it is free? Interatomic space. That interatomic space is nothing but conduction band. When this electron will be present in the conduction band, then when the electron is available in the conduction band, only when temperature is greater than 0 degree Kelvin. When the temperature is greater than 0 degree Kelvin means definitely there is what hole. There is hole in where in valence band. Where in valence band. If there is a hole means it has a positive charge. It has positive charge. And definitely electron is also there. Definitely electron is also there. Electron has negative charge. Means negative positive means there is a force of attraction. Which type of electrostatic force of attraction? That electrostatic force of attraction will affect what? Will affect the motion of what? Motion of electron. Where? In conduction band. In conduction band means what? In interatomic space. In interatomic space means what? Inside the crystal. Inside the crystal. It will affect the movement of this movement of this electron. Okay. So why? Because its mass will get affected by this force of attraction. Okay. So this is what basic understanding. Okay. So but here this electron is in free space. Where? In free space. Okay. For example, understand it as a what it is inside the conductor, perfect conductor. So here what electron is free? Electron is free because inside the conductor, let us assume that it is inside the conductor. Okay. It is inside the conductor and it is inside the semiconductor. This is inside the semiconductor, which is silicon semiconductor. Okay, this electron is in free space. Free space means it is in conductor. When it is in free space, only when we are applying what? External potential, like both across both we must apply what? We must apply what? Potential. We must apply potential. Why? To maintain, to align all the electron in one particular direction. One particular direction to make the flow of electron in one particular direction means it is a conduction. It is nothing more than conduction. Okay. So this is what conduction. When we apply this what? Potential, it will give us what? Electric field. Okay. So let us say electric field is in this direction. Okay. So this is my electric field from positive to negative. Then this electron will move in opposite direction, this side. Okay. So this side, this electron movement is in opposite direction of this electric field. Let us say these are electron moving. Okay. So then current is from this side. Okay. So this is what movement of electron. Okay. Movement of electron. Now this is what? External force or not? This is external force. Why we are applying this external force? That we know very well. In every conductor, every type of conductor, we must apply what? Potential to establish what? Electric field. Why electric field? What is the purpose of electric field? Is that it will what? It will align all the electron in one particular direction, so that we will so that what? So that this conductor is able to conduct. Okay. So that current will flow through the device. Okay. Through the device. That is valid for every conductor. In conductor also we must apply what? Potential across this. Okay. So we must also apply potential across this. Okay. Across this. So potential across this, positive, negative. Okay. Here also electric field this direction, and electron direction opposite. Okay. So here also current will flow. Okay. So now, but the difference is only, what is the difference here? Difference is only that here with an external force. Okay. So in this, so see here, the difference is only in case of semiconductor. See, in case of semiconductor in case of semiconductor means silicon crystal. Okay. Means silicon crystal. In case of semiconductor means silicon crystal force. Force is equal to F external force. F external force that we are applying externally by applying potential. Okay. In order to establish the electric field. So that force. Okay. So that electric field is nothing but force per unit charge. So it is applying the force in charge. Which type of charge? Negative charge. That is electron. Okay. In one, to align them in one particular direction. This is that force, external force. Plus with this external force, there exists an internal force. That is my electrostatic force. This is my internal force. What? Internal force. Okay. So this is what present in what? This is present in semiconductor. Okay. In semiconductor. Same if I will say for what? Conductor. If I will say for what? Conductor. Okay. So this is my conductor. Conductor means the electron is in free space. Okay. So now see here, electron is in free space. So electron is in free space means what? means what? There does not exist any external force. Okay, it is in free space, there is no hole, nothing is there, so therefore there is no positive charge, there is only electron, there is only electron, negative charge. Okay, only one type of charge, only one type of charge is there, so therefore there exists no external force. Okay, so there does not exist any internal force, there is only, in this conductor there exists only what? External force. This is my F is equal to F external. F external force. This is in case of what? Conductor. This is in case of what? Semiconductor. In case of semiconductor. Why? Because there is a formation of allowed energy band, that is conduction band, valence band. But there is no conduction band, there is no valence band, only conduction band. Okay, so only conduction band means there is no hole. Okay, if there is no hole means there is no positive charge particle, means there is no force of attraction. So means there is no internal force, internal electrostatic force of attraction, but there is an internal force which is electrostatic force of attraction, which is what? Which is influencing the what? Motion of electron inside the crystal. Okay, inside the crystal means in conduction band. Okay, that is what conductor. Whenever I am saying what? Electron in the free space, just understood that that electron inside the conductor, inside the conductor. Okay. Whatever the electron we are assuming inside the crystal means it is inside the semiconductor, inside the semiconductor. This is the basic, this is what the basic difference between this. Okay, this is external forces same, because in order to conduct, in order to make the, in order to make any material to conduct, we must apply what? We must apply what? We must apply the potential, which is what? Acting like an external agent. Okay, so then due to which there is a establishment of electric field. Okay, to maintain this electric field we must apply the potential. Okay, so that is valid in both, every conductor, that is valid. Okay, so it must be applied in every conductor. But in semiconductor, externally, in addition to this, there exists an internal force, there exists an internal force. Okay, so that is due to what? This positive and negative charge. This is because of what? Valence band. Okay, valence band. In valence band there is a creation of what? Positively charged empty state, empty state. Okay, one positive, one negative. Wherever positive, negative is there, definitely there is internal, there is an electrostatic force of attraction. So definitely then what happens? This will influence the motion of a electron. Which type of motion of, which type of electron? Free electron. Where? In conduction band. Okay, in conduction band. So it is what? It is affecting the motion of this. Okay, so due to which its mass will get affected. See, this, and this force is equal to what? This force is equal to mass into acceleration. Okay, this is what? This force is equal to mass into acceleration. This force, this is mass into acceleration. This force is equal to mass into acceleration. Okay, now I am going to write this mass into acceleration only for semiconductor. Mass into acceleration is equal to F external force. F external force plus F internal force. Okay, which will affect the motion of what? Electron inside the crystal. Let us say that its mass will get affected like this, m1. Okay, m1 into a. Okay, m1 into a. Then F external force. F external force is equal to what? F external force is equal to ma minus m1a. m1a. Okay, now what to do? Just here take m minus m1, m minus m1 into a. Okay, so this is my what? F external. F external is equal to m minus m1 into what? A. So this is my F external force. Okay, so this m minus m1 is nothing but, see here, F external force is equal to effective mass into what? A. Okay, so now in this way we can define this what? Effective mass. Okay, effective mass inside the semiconductor crystal, semiconductor crystal. Why? Because in general what happen? The electron inside the crystal has different movement compared to the electron which is present in free space, or in free space, or you can say inside the conductor, perfect conductor. Okay, so because because in addition to what, in addition to external force, in addition to external force, there exists an internal force, which is nothing but, electrostatic force of attraction due to positively charged ion. You can see that as a proton, or the negatively charged particle, that is electron. And this force of attraction, which is electrostatic force of attraction, influence the or affect the motion of electron inside the crystal. Means it will affect the motion of electron in the conduction band, or in interatomic space, or in inside the crystal. Okay, inside the crystal. So this is what effective mass. Okay, effective mass. Now for this effective mass, we can say that it is a mass which take the mass of particle, okay. It is a mass which take the mass of the particle into the account with the effect of into the account with the effect of what, with the effect of internal force. Okay, what is effective mass? Effective mass is a mass which take the mass of the particle into the account along with the effect of internal force. And that force is nothing but electrostatic force of attraction, which is formed due to the positively charged empty space. That is what, positive charged ion, or you can say it as a proton, and what, negatively charged electron. Okay, so therefore between this there is a electrostatic force of attraction. Okay, so this is because of this. Okay, because of this inside valence band. Okay, so this is what about the effective mass. Okay, effective mass inside the semiconductor crystal. Okay, so now this mass that we can write. Okay, you can now note down this first. Okay, note down this completely. Okay, so then after that we will go further. See here. Okay, now see here, this effective mass, it can be positive, it can be negative, or it can be zero. Okay, so this effective mass. Okay, so effective mass can be positive, negative, and zero, neutral. See, this is my effective mass. Effective mass that can be positive, greater than 0, when m is greater than m1. This can be negative when m is less than m1, and it can be 0 when m is equal to m1. Yes, so this is what effective mass. So now we will see the electron in free space. For electron in the free space or free particle, we will see ek diagram equation. Okay, equation of energy versus momentum. Equation of energy versus momentum for the free electron, or the electron in the free space. In the free space, we are going to derive one equations, parabolic equations. Okay, so from there we will get some result. Okay, so then after that we will apply that result into conduction band and valence band. Why? Because we want to actually see the effective mass of electron in the valence band and conduction band, whether it is positive or negative. Okay, so in both band we want to see the effective mass of electron. For that we are going to see first what, we are going to see first the ek diagram equations. Okay, we will apply to electron in the free space or for free particle. Okay, so let us see first. This board has got blurred by what, this ink. Okay, so let us see, let it be. See here, now what we are going to see, we are going to see ek diagram. Oh shit, sorry for that guys.